Good morning, students. Let us today begin literally the first module of your third sem complementary chemistry course, that is organic chemistry. The first module of this paper, this course is organic chemistry, some basic concepts. In the last class, we have done as an opener, a starter, explaining how we could draw structures. We discussed some fundamental concepts in organic chemistry, especially how you can draw structures. Okay. Today we discuss some basic concepts related to organic reactions. This is another area where you should be very confident to make organic chemistry learning quite easy. First of all, we discuss what is called curved arrow formalism. Even though it is not explicitly mentioned in the syllabus, it is much required for you in learning organic reactions. You might have seen when you go into reaction mechanism, resonance, etc., we make use of these arrows, curved arrows. This you will see organic chemistry book. Curved arrows. What is the use of this arrow? To show the movement of electron. Arrow ne tailum headum now. Tail is the source of electron, and head indicate the destination. So it is a kind of electron bookkeeping. Electron in a movement. There is full arrow, full headed arrow. It indicates movement of two electrons. This tail, it can be from a bond pair or a lone pair. Okay, and it can go to a particular atom or in between atoms. Means it can change into a bond pair or lone pair. What is this? This is a half-headed arrow indicating movement of only one electron. This is also called fish hook, right? Okay. Now, to explain this use of arrow, let me take two examples. This is acetate ion. You know that. Acetic acid is H plus acetate ion. Carboxylic acid is in the acidity explained, it is because of resonance stabilization of this carboxylate ion. So there is resonance here. This resonance is arrows. But this lone pair is arrow correct use. Start the lone pair, end the bond in the middle. Because it bond pair. And consequently, this bond pair will go to this oxygen, becoming a lone pair. So the next resonance structure will come like this: CH3. C is single bond O, this is double bond O. So lone pairs O, here രണ്ടെണ്ണം, ഇവിടെ മൂന്നായി കൂടും, negative charge ഇവിടെ വരും. Okay. So we make use of these curved arrows like this in drawing resonance or in reaction mechanism, etc. In this example, this is a single electron free radical or simply radical. But here, one electron this bond is resonance. We will resonance. This electron is one electron. So we have half-headed arrow. This electron is a double bond. So the structure will be now CH2. This bond break is single bond CH. This double bond CH2. You follow? This electron is the double bond. About electron that means it will appear as a radical end. But an unpaired electron. So this is resonance stabilization in this species. This is actually called allyl radical. Allyl is this group. Allyl free radical. Okay. So that's about curved arrow formalism. We will extensively make use of this practice in this chapter as well as in all other organic chapters which deal with reactions. Fine. Let us now go to the next one, types of bond fission. See, when you discuss organic reactions, we know that during a reaction, the bonds on the part of the reactants breaks and new bonds are formed on the part of the product. About breaking of bond, that's a reaction. How do you bond break? A covalent bond break? Break. That is, there are two types of bond fission. One is called homolytic fission or homolysis, and the other is called heterolysis. Right? That is, for example, let's take AB. This is a bond, covalent bond. Suppose this bond pair 2 electron davullo. This 2 electronum homo ennu parnal endana same. That means this bond can break symmetrically, equally, such that each fragment get 1 electron each. Appo nammal ivade curved arrow ubhayikkunnu nokka, half-ended arrow ubhayikkanam. This bond break cheyunnu angane kittunna endana, you get A with 1 electron plus B with 1 electron. This is called homolytic cleavage, right? Due to this homolytic cleavage, what is the product? You get free radicals. Remember that. So free radicals are obtained by homolytic fission. And now what are free radicals? They are neutral species containing unpaired or odd electron. They are quite reactive because they try to pair up, right? Now, what about heterolytic fission? Another possibility is that this bond can break in such a way that both the electrons in the bond is taken by one of the fragment. എന്ന് വെച്ചാൽ ഇതിൽ ഏതാണോ more electronegative ആ atom 2 electron എടുക്കും. അപ്പോൾ നമ്മൾ full arrow ഉപയോഗിക്കണം അവിടെ, right? So what you get here? You get what about A? ഈ 2 electronum B എടുക്കുമ്പോൾ ഈ A യുടെ ഈ 1 electron അതിന് നഷ്ടപ്പെടുന്നുണ്ട്. അപ്പോൾ A become plus. What about B? B getting this electron also, adinte electron ചേർന്ന് അതൊരു lone pair ആയി മാറും, and it will have a minus because it got 1 electron extra from A. You are getting ions here. So heterolytic fission result in formation of ions, positive and negative ions. In organic chemistry, these are better called electrophiles and nucleophiles, right? We will take examples to explain this. Coming to homolytic fission, one example for homolytic fission, this is a very popular reaction. The chlorine molecule which undergo cleavage in presence of UV light, you know what takes place, what is responsible for ozone depletion, the chlorine radicals are formed. ഇവിടെ ഈ chlorine ഈ bond ഇങ്ങനെയാണ് split ചെയ്യുക. You are getting chlorine radicals 2 chlorine radicals. Another is, peroxide bonds are very susceptible for homolytic cleavage. This bond pettannu break cheyum. Peroxide bond, this is H2O2, hydrogen peroxide. So this bond will break in this way, forming OH radical, hydroxyl radical, 2 molecules. Radicals are also important in many antioxidant properties or reactions taking place in our body also. Biology students will be knowing it. Fine. Now, in organic chemistry, this H is replaced by R. Then it is very important compound in organic chemistry, which is called organic peroxides. Or this is alkoxy group. You are getting OR dot. That is called alkoxy radical. This R can vary like methyl, ethyl, benzyl, phenyl, etc. Right? Giving different types of organic peroxide. Peroxides are important in antimarconic of addition. You might learn somewhere else. Fine. Now coming to examples of heterolytic fission, let me take a very simple example, HCl. HCl is a very useful reagent in many reactions in organic chemistry. This will break in favor of chlorine. You know, chlorine is more electronegative. അതുകൊണ്ട് എന്താ വരിക? H plus plus Cl minus dot. Remember, when we put negative charge, it does mean there is a lone pair, even though it is not explicitly shown. അപ്പോൾ ചില ബുക്കിലൊക്കെ നമ്മൾ ഇങ്ങനെ ലോൺ പെയർ ഇട്ട് കാണിക്കും, ചിലതിൽ ഇടാതെ കാണിക്കും. രണ്ടും സെയിം ആണ്. ഒരു നെഗറ്റീവ് ചാർജ് ഉണ്ടെങ്കിൽ റിമെമ്പർ ദർ ഇസ് എ ലോൺ പെയർ. ഓക്കെ, യു ക്യാൻ ഫോളോ ബോത്ത് വേ. Another reaction you might be discussing in another module about this reaction, that is nucleophilic substitution reaction. For example, this is a tertiary halide. This easily breaks like this, forming carbocations, right? You are getting this carbocation. This is a positive one, and plus Cl minus. These are examples for heterolytic fission. Okay, we wind up this part. Now we go to the next thing, that is what is called what are the types of attacking reagents which occur in organic reactions. Mainly two. There are so many attacking reagents. What are attacking reagents? During an organic reaction, it is that there will be a trigger of the reaction. An attacking reagent will attack the substrate and reaction triggers. അപ്പോൾ അങ്ങനെ റിയാക്ഷൻ തുടങ്ങാൻ കാരണമാകുന്ന അറ്റാക്കിംഗ് റിയേജൻറ്റ് പ്രധാനമായിട്ട് രണ്ട് ടൈപ്പാണ്. ഒന്ന് ഇലക്ട്രോഫൈൽ. ഞാൻ നേരത്തെ അത് സൂചിപ്പിച്ചു. ഡ്യൂറിങ് heterolytic cleavage, electrophiles and nucleophiles are obtained. So what is electrophile and what is nucleophile? You might be knowing it right from your +2 level. Nucleophile. Remember, many topics we discuss here are all what is familiar to you, but remember in learning, revision is something what is essential for further go. Okay, എന്താണ് electrophile? Electron file means loving, electron loving species, a species which is electron deficient and attack electron rich center. It attack electron rich center because it is electron seeking. Itself is electron deficient, right? It is formed by heterolytic fission. We can call them, we can treat them as Lewis acids because anything which is electron deficient is Lewis acid which can accept electron pair. Putting example, very common example, see H plus ion. This is electrophile because it's positive ion and it is electron deficient. It will attack electron rich center to get electron. Another is NO2 plus. In nitration reaction, this is an electrophile. Now electrophile can also be molecules like PF3, AlCl3 and also SO3 etc. ഇവിടെ രണ്ട് തരം എക്സാമ്പിളാണ് പറഞ്ഞത്. ഇതൊക്കെ പോസിറ്റീവ് അയൺസ് ആണ്, ഇത് ന്യൂട്രൽ മോളിക്യൂൾസ് ആണ്. അപ്പോൾ ഇലക്ട്രോഫൈൽ എന്ന് പറഞ്ഞാൽ ഇറ്റ് ഈസ് നോട്ട് നെസസറി ദാറ്റ് ഇറ്റ് ഷുഡ് ബി പോസിറ്റീവ് ആണെന്നില്ല, ഇറ്റ് ക്യാൻ ബി ന്യൂട്രൽ ആൾസോ. എങ്ങനെയാണ് പിന്നെ ഇത് ഇലക്ട്രോഫൈൽ ആകുന്നത്? If you look into the Lewis structure, you can see that this is electron deficient, incomplete octet. You will try to accept electron. It is Lewis acid. SO3, you know, SO3 is having this kind of structure with double bond with oxygen. Since this is a pi bond, it will try to move towards oxygen due to resonance, and the sulfur get partial positive charge. So sulfur is an electrophilic center, or it is electron deficient. Sulfur is electron deficient, so SO3 can altogether act as an electrophile. Now coming to the next one, that is nucleophile, just opposite. എന്താണ്? ന്യൂക്ലിയസ് ലവിങ്. എന്താ ന്യൂക്ലിയസിൻ്റെ പ്രത്യേകത? പോസിറ്റീവ് ആണ്. അപ്പോൾ ഇലക്ട്രോൺ ഡെഫിഷ്യൻ്റ് ആയ സെൻറ്ററിനെ അറ്റാക്ക് ചെയ്യുന്ന സ്പീഷീസ് ആണ് ന്യൂക്ലിയോഫൈൽ. അപ്പോൾ അതുകൊണ്ട് ഇറ്റ് സെൽഫ് വിൽ ബി വാട്ട്? ഇലക്ട്രോൺ റിച്ച്. സോ വി ക്യാൻ സേ ന്യൂക്ലിയോഫൈൽ ഈസ് എൻ ഇലക്ട്രോൺ റിച്ച് സ്പീഷീസ് എന്ന് പറയുമ്പോൾ it should have at least one lone pair. Electron rich എന്ന് പറയുമ്പോൾ അതിൽ ലോൺ പെയർ ഉണ്ടാവണം. അപ്പോൾ ലോൺ പെയർ ഉള്ള ഒരു സ്പീഷീസ് വിച്ച് അറ്റാക്ക് ഇലക്ട്രോൺ ഡെഫിഷ്യൻറ്റ് സെൻറ്റർ. ഓക്കെ, because it has a lone pair, it can be treated as Lewis base. Putting example, Cl minus, okay, Cn minus, NH2 minus, these are all negative ions. Definitely they will have lone pair, at least one lone pair. And writing some other examples like H2O, NH3, ROH. ROH is alcohol. These are neutral molecules, but they are also nucleophile. Why? Because they have a lone pair. So the essential condition for a nucleophile is what? It should have a lone pair. It can be negative or neutral. Apart from these two, we can also treat free radicals also as attacking reagents, because there are reactions triggered by free radicals, which we already mentioned. We will discuss more about free radicals later on. Finally, today we I'm giving an introduction about another very important concept in organic chemistry. This is most important: electron displacement effects. See, in organic molecules, we can see that more electrons get shifted, they move, they get delocalized due to various reasons. There are different phenomena by virtue of which electrons get delocalized, means they move along the molecule, which substantially influence its properties. This electron displacement effects in the pratyekada molecule in the property aage മാറ്റിമറിക്കും എന്നുള്ളതാണ്. റൈറ്റ്? ഇത് നമുക്ക് വിശദമായിട്ട് പഠിക്കാനുണ്ട്. ഈ മൊഡ്യൂളിലെ ഏറ്റവും മെയിൻ ഡിസ്കഷൻ ഇതാണ്. ഓരോന്നും വിശദമായിട്ട് പഠിക്കണം. ഐ എം ഗിവിംഗ് ആൻ ഇൻട്രൊഡക്ഷൻ ടുഡേ. See, the displacement effects can be divided into two types mainly. One is permanent effects. Permanent effects il പെടുന്നതാണ് inductive effect, resonance effect and hyperconjugation. ഇത് മൂന്നും permanent effects ആണ്. Right? Actually, I mean like this. See, these three come under the same type, and this is another one. എന്താണ് ഇലക്ട്രോമെറിക് ഇഫക്റ്റിന്റെ പ്രത്യേകത? ഇതൊരു ടെമ്പററി ഇഫക്റ്റ് ആണ്. അപ്പോൾ ഈ മൂന്ന് ഇഫക്റ്റും ഇൻഡക്റ്റീവ് ഇഫക്റ്റ്, റെസൊണൻസ് ഓർ മെസോമെറിക് ഇഫക്റ്റ് and hyperconjugation, these electron displacement effects are permanently present in the molecule, but this one is temporary. ഇത് ടെമ്പററി ഇഫക്റ്റ് ആണ്. എന്ന് വെച്ചാൽ അത് ഒരു മോളിക്യൂളിൽ ഒരു റിയാക്ഷൻ നടക്കുന്ന ആ കണ്ടീഷനിൽ ഒരു അറ്റാക്കിംഗ് റിയേജൻറ്റിൻ്റെ പ്രസൻസിൽ മാത്രമേ ഇലക്ട്രോമെറിക് ഇഫക്റ്റ് നമുക്ക് കാണാൻ സാധിക്കുകയുള്ളൂ. Now, what are the differences between these three? ഒന്ന് പറഞ്ഞു, these three are permanent effects, this is temporary. Another is inductive effect involve movement of sigma electrons. Sigma ബോണ്ടിലുള്ള ഇലക്ട്രോൺ ആണ് അതിൽ മൂവ് ചെയ്യുക. ഇൻഡക്റ്റീവ് ഇഫക്റ്റിലുള്ളത് സിഗ്മ ഇലക്ട്രോൺസിൻ്റെ മൂവ്മെൻ്റ് ആണ്. എന്നാൽ റെസൊണൻസ് ഓർ മെസോമെറിക് ഇഫക്റ്റ് ഈസ് the movement of pi electron, which is supported by n electrons also. What is n electron? N electron means the lone pairs, non-bonding electron. നമ്മൾ സാധാരണ മോളിക്യൂൾ കാണാറില്ലേ ലോൺ പെയർസ്, CH3, COH, etc. Here the lone pair. Here these are the bond pairs, this is the lone pair. അതിന് n electron എന്നും പറയും. അപ്പോൾ പൈ ഇലക്ട്രോൺസ് ആണ് ബേസിക്കലി റെസൊണൻസിൽ ഉള്ളത്. പൈ ബോണ്ട് ഉണ്ടെങ്കിൽ മാത്രമേ റെസൊണൻസ് ഉള്ളൂ. പക്ഷേ ഇറ്റ് ഈസ് ഫെസിലിറ്റേറ്റഡ് ബൈ n electrons also. And what is hyperconjugation? Is a very special kind of electron displacement effect involving sigma as well as pi. So it's a mixed type sigma pi interaction. The electron displacement which involves sigma as well as pi orbitals or electrons. And electromeric effect is purely involve movement of pi electrons. Now these are abbreviated. Inductive effect is I, capital I. This is capital R and capital M. Mesomeric effect is the former name of resonance effect. We now use this name. Hyperconjugation doesn't have any such abbreviations. Electromeric effect by letter E. These abbreviations are because all of these are of two types, like inductive effect is plus I and minus I, plus R and minus R, plus E and minus E. We will go to the details in the next class. In each class, we will discuss one electron displacement in detail. Okay? So, go thoroughly through it, make the notes, and you can come with any doubts in the group or personally. So, Till then, bye.